Hello! Mabuhay everyone! This is your team BeKeeNi. This is Be for Benijan Nico Heruta.
That's me, Keesha Joy Libertad.
And for me, Nick Aaron Caballero.
And welcome to our vlog! Nick,
Uy.
may data na. Pwede ko ka-connect.
Oh, sige.
Hindi, basa lang ko kay sir.
Okay.
Parang ito tong deadline.
Ara na? Okay. Thank you. Go.
Benny, do you have the data about the demographics of our respondents?
Oh, here.
Nice. Thank you.
No Facebook, no IG, inner peace.
Hey, Rex! Did you know that Nina posted?
No, I'm fine. I already deleted my socials.
I see. Oh, did you know that your crush in high school is already getting married? Oh, and someone said a T in our GC. I forgot. You already deleted your account. Oh, I have to go. Bye. Data can be observed in various fields and aspects of life. If we collect data even in just one field, we will have a huge amount of it. A quantity that could possibly be similar to the number of stars we see at night or more.
That's very correct. In the field of computers, in order for this data to be used in real life and help us improve, we must analyze it.
But how are we able to analyze such big data?
That's what we are going to find out today. So are you ready?
Then sit back and listen carefully as we will introduce you to the world of big data.
Let's define data first. Hey, Chat Nikki, can you please define data in the field of computers?
Sureness, Benny. According to Knowledge Hack Upgrade 2017, data are quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical media. In simple words, we can say that all the facts and figures which can be stored in digital format can be termed as data. All the text, numbers, images, audios, videos stored in our phones and computers are some examples of data.
Now, computer programs in their fundamental sense accept data for processing and return a result. An example would be observed in sending a text message, just like this. Tapos.
Okay.
When you send a message through a text messaging app, the app acts as a computer program that accepts the message as input data and processes it to facilitate the delivery of the message to the intended recipient. Once the message is successfully sent, the app returns a result in the form of a confirmation or delivery status.
Now, imagine if thousands of Nick or millions of Nick make a message and send it. That would be too many and large data is involved. This analogy can be used to imagine big data.
According to Gotkar and Rockdead 2016, big data is a torrent of information generated by machines or humans which is so huge that traditional databases fail to process it. It includes diverse sets of information that grow at ever-increasing rates.
There are three V's that can be used to characterize big data as introduced by Gartner analyst Doug Laney in the 2001 research publication. These are volume, velocity, and variety.
Volume means the amount or quantity of data. As the name suggests, big data has a huge volume. And this size is not something comparable to the number of individual grains of rice present in a serving of a meal. In fact, it is estimated that 2.5 quintillion bytes of data are created each day. And by 2020, there will be 40 zettabytes of data created, which is an increase of 300 times from 2005.
Velocity is the speed at which the data is created, stored, analyzed, and visualized. Generally, big data are produced in a short period of time, which could mean that these have high velocities. An example of this, according to estimates, is approximately 900 million photos are uploaded by Facebook users every day.
And variety means the number of types or sources of data. Big data encompasses diverse data types, including structured, semi-structured, and unstructured data.
Go. We mentioned earlier about the structured, semi-structured, and unstructured data. Now let's ask ChatNikiti about this. Hey ChatNikiti, can you briefly explain to us what are the structured, unstructured, and semi-structured data? Sure.
Hello there! Structured data. This type of data has a well-defined schema or model. It is organized in a tabular format with rows and columns, where each column represents a specific attribute or field. Examples of structured data include relational databases and spreadsheets. Semi-structured data. This type of data falls somewhere between structured and unstructured data. It does not fit neatly into a tabular format like structured data, but it has some organizational properties that make it more usable than unstructured data. Examples of semi-structured data include XML and JSON files. Unstructured data. This type of data does not have a predefined data model or format. It is often text-heavy and can include data such as emails, social media posts, and multimedia content. Unstructured data is more challenging to analyze compared to structured data.
Thank you very much, ChatNikiti. Now, you might be asking, how can we analyze that big data?
The answer to that is big data analytics. Big data analytics refers to collecting, processing, cleaning, and analyzing large data sets to help organizations operationalize their big data.
Data collection. The first step is to gather data from various sources. The data is collected and stored in a suitable format for analysis.
Once the data is collected, it needs to be cleaned and pre-processed to ensure its quality and consistency. This involves removing duplicates, handling missing values, standardizing formats, and transforming data into a suitable structure for analysis.
In many cases, data from different sources needs to be integrated to create a comprehensive data set. This involves combining data from various databases, systems, or external sources to provide a holistic view of the information.
Exploratory data analysis. The next step would be the conduct of an exploratory data analysis. This involves examining the data to understand its characteristics, identify patterns, and gain initial insights. This can include statistical analysis, data visualization, and summary statistics to explore relationships and trends within the data.
Various analytical techniques are then applied to extract insights from the data. This can include descriptive analytics, which summarizes past data, diagnostic analytics, which helps understand the causes of problems, predictive analytics, which predicts future outcomes, and prescriptive analytics, which provides recommendations for decision making.
Machine learning algorithms and data mining techniques are often used to uncover hidden patterns, relationships, and trends within the data. These techniques can help in making predictions, identifying anomalies, and discovering valuable insights that may not be apparent through traditional analysis methods.
Visualization and reporting. The results of the analysis are often visualized through charts, graphs, and dashboards to make them more understandable and accessible. Reports and presentations are created to communicate the findings to stakeholders and support decision-making processes.
Let's have an example. Imagine a large retail chain with stores across the country. They collect vast amounts of data on a daily basis, including sales transactions, customer demographics, product inventory, and customer feedback. Here's how they analyze this big data.
The retail chain uses a point of sale systems to capture detailed information about each sales transaction, including the products purchased, the time and the location of the sale, and the customer's payment method. The collected data undergoes cleaning and pre-processing to remove any errors, inconsistencies, or missing values. This ensures the accuracy and reliability of the data. The retail chain combines data from various sources such as sales data, customer data, and inventory data to create a comprehensive data set for analysis.
Exploratory data analysis. Data analysts perform EDA techniques to gain an initial understanding of the data. They may analyze sales trends over time, explore correlations between products, and identify patterns in customer purchasing behavior. Sales performance analysis. The organization analyzes sales data to evaluate the performance of different products, brands, or store locations. This analysis helps identify top-selling products, underperforming items, and opportunities for improvement. Customer segmentation. Using customer data, the organization segments its customer base into groups based on demographics, buying patterns, or preferences. This segmentation helps tailor marketing campaigns and promotions to specific customer segments for better targeting and personalization.
Inventory management. By analyzing sales data and inventory levels, the organization can optimize its inventory management processes. They can identify popular products that require replenishment, reduce stockouts, and minimize excess inventory. Pricing analysis. The organization analyzes sales data and competitor pricing to determine optimal pricing strategies. They can identify price elasticity, seasonal price trends, and opportunities for promotional pricing. Sentiment analysis. The retail chain analyzes customer feedback data, such as reviews and social media mentions, to understand customer sentiment towards products, services, and the overall brand. This analysis helps identify areas for improvement and enhances customer satisfaction.
Predictive analytics. By applying predictive analytics techniques, the organization can forecast future sales, predict customer churn, or anticipate demand for specific products. These insights support proactive decision-making and planning. Visualization and reporting. The analyzed data is visualized through interactive dashboards and reports. Visualizations such as charts, graphs, and heat maps help stakeholders easily grasp the key findings and make informed decisions.
And that's it everyone, our Madlang Watchers.
I hope you learned something big from us today.
Until the next video!
Bye-bye!